Welcome to this how-to video on Azure NetApp Files Large Volume Breakthrough Mode. My name is Ranga Shankar and I am a product manager for Azure NetApp Files. In this video, we will walk through the steps for setting up a large volume in breakthrough mode and review the performance results we have published. Who is this feature for? Organizations needing maximum performance, bandwidth, and consistent IOPS, as well as industries such as semiconductor, hyperscale, and teams requiring support for extremely large datasets and global collaboration will find this useful. Azure NetApp Files Large Volume Breakthrough Mode with 6 storage endpoints on dedicated capacity enables high-performance, low-latency access for large-scale workloads. It simplifies network management and eliminates performance degradation. So how does this feature work? It deploys 6 NICs in the customer's delegated subnet to support a single large volume in breakthrough mode. Dynamic scaling from 2400 GIBs to 2400 TIBs with flexible configurations is possible. Dedicated capacity ensures exclusive resource allocation and consistent performance. So why is this important? It provides industry-leading scalability, performance, and flexibility that is trusted by top organizations for their demanding data needs. We shall now demo a setup of a large volume with breakthrough mode enabled. Use the QR code shown here to access the large volume requirements and considerations. Before creating Azure NetApp Files large volumes, customers must register for the large volume feature and ensure the required capacity is approved. For large volume breakthrough mode requires a separate registration. Use the AZ feature show, name ANF large volumes, and follow that with AZ feature show, name ANF breakthrough mode to make sure the features are registered. For this setup, we used the virtual machine scale set to create 6 VM instances. Choose the correct resource group, region, authentication, and a scale set name. Make sure the validation is passed. Click Create. The deployment of 6 VMs will take a few minutes to complete. Once the deployment is complete, you can verify all the VM instances are provisioned and running. You can see all the VMs with the scale set name prefix we created. You can also see the public IP addresses. Using SSH, log in to all the 6 VMs. Make sure to use the username password combination that was used when setting up the VMs using the VM scale set. Here we create a capacity pool named LVBT cap pool with flexible service level and 60 TIBs. The next step is to create the volume. Create a volume by name LVBT cap pool vol1. Choose a size of 60 TIBs. Choose large volume. Click on the breakthrough mode radio button. Choose the correct virtual network. For protocol, choose NFS v3. Click Create, and this should create the volume. It will take a few minutes to deploy, and once deployment is complete, you should be able to see the volume with 6 mount paths. In the VM, under the mount directory, create a mount point, lvbt cap pool vol1. Use the mount command shown in the mount instructions and mount the volume. After a successful mount, DF should show the mount point and the mount from the IP address. The NFS v3 mount commands specify the exact command to run on each of the 6 VMs. Follow the mount instructions as shown earlier, and from each VM, mount the volume through different highlighted storage endpoints. After the mounts complete, run a DF command on each VM to confirm the volume is mounted via the 6 different storage IP endpoints. Use VI and create a test file from each of the VMs. write some test content, and save the files. Suffix the name of the VMs to the test files. Make sure the test file contents are different in the 6 VMs. This will allow us to differentiate the test files when a ls or a dir command is executed later. Here you can see ls from one of the VMs listing all the 6 test files created from different VMs. Also, the df from different VMs lists the IP mount points from which the volume can be accessed. This setup showcased the steps to create a large volume with breakthrough mode enabled and the ability to access it through the 6 storage endpoints from various VMs. Next, we will review performance benchmarks for large volume breakthrough mode. The Learn article on large volume performance benchmarks for Linux explores scenarios for scale-out read and write workloads. FIO, a synthetic load generator, is used to drive these test results. The sequential workload shows a single large volume in breakthrough mode handling more than 50,000 MIPS per second pure reads and more than 21,000 MIPS per second pure writes. For random I/O workloads, it can handle 1.8 million pure reads and close to a million pure writes. SPECstorage2020 provides a vendor-neutral, application-driven benchmark that reflects how storage behaves under real EDA workloads. With that context, what you're seeing here are SPECstorage2020 EDA blended results that highlight Azure NetApp Files large volumes in breakthrough. In this first result, a single large volume in breakthrough mode sustains 2,880 EDA job sets with an overall response time of approximately 0.51 milliseconds, demonstrating strong performance even at high concurrency. When we scale out to 6 large volumes, also in breakthrough mode, the system scales linearly to 17,280 job sets while maintaining a sub-millisecond overall response time of about 0.60 milliseconds. Together, these results validate that Azure NetApp Files large volume breakthrough mode delivers both high performance and predictable scaling, which is critical for demanding large-scale EDA environments. Thank you for taking the time to watch this how-to video on large volumes with breakthrough mode enabled. We hope you enjoyed the video and found it useful. You can scan the QR code or go to the Learn article shared here to get more details on large volume breakthrough mode.